Okay, Crystal, we're going to go through the problems you missed so that you know what you did wrong, and then you can take the practice test again. So let's start with question number 3. So it says, find the mean of the given probability distribution. It says, in a certain town, 30% of adults have a college degree. The accompanying table, that's this one, describes the probability distribution for the number of adults among 4 randomly selected. So we want to find the mean of this probability distribution. So we're going to put this in our calculator. And we're going to go to Stat and Edit. And we're going to put the X values in L1. So 0, 1, 2, 3, and 4. And then we're going to put the P of X values here. So, oops, sorry. I'm going to pause this while I put the numbers in just so you don't have to watch me do that. Okay, so I have all of the values in L1 and L2. Now we're going to go back to the home screen and we're going to hit Stat, over to Calc, one variable stats. Now this is a very important part. After this, we need to put L1, comma, L2. So we're going to hit second, the L1's right here, comma, second, L2, and we're going to hit enter. And the mean is this first value, X bar. So 1.2 is our answer. And you can see that's the answer there. Okay, so we're going to go to 4. So 4 says, find the standard deviation, sigma, for the binomial distribution, which has the stated values of n and p. Round your answer to the nearest hundredth. So that's the second decimal place. So it says n is 27, and p is 3/5. Now, we're going to also need q, and remember, q is 1 minus p. So here it'll be 1 minus 3/5. And if you do that in your calculator, you're going to get 2/5. Now, for a binomial distribution, the standard deviation is the square root of n times p times q. So we're going to have the square root of 27 times 3/5 times 2/5. So we'll put that in our calculator. So square root of 27. We can actually just do times 3/5. Oops. Be careful about not putting too many parentheses here, because like if you close the parentheses after 27, it won't do it all right. It'll only have the square root of the 27 under the square root. So we want to be careful not to put too many parentheses in here. 2/5. Okay, so 2.55. Be our answer. Okay, we're going to go to number 5. So it says, an insurance company charges a 21-year-old male a premium of $250 for a 1-year, $100,000 life insurance policy. 21-year-old male has a 0.9985 probability of living for a year. Okay, so we're going to talk about if he lives or if he dies. Now, if he lives, he doesn't need the life insurance. So he's lost all of the money he paid for it, $250. So it'd be a negative $250. If he dies, his family gets $100,000. What we have to be careful here is they paid $250 for it, so the value of it would be $100,000 minus the $250. Okay. Now, the expected value, we're going to set up a chart. So we'll have our money and the probability of that. And he either lives or dies. So if he lives, he's out $250. If he dies, his family gets $99,750. Now it says he has a 0.9985 probability of living. So his probability of dying would be 1 minus that, which will be 0.0015. So we need to put this in L1 and L2. over here we're going to put negative 250. Oops. 50. Oh, you know what? It put in a minus sign instead of negative. Okay, and then 99,750. And then over here we're going to put 0.9985 and 0.0015. Okay, so now we're going to do stat. Remember, we want one variable stats, and then we need to put in the L1, comma, L2. Okay, and the mean will be our expected value. So our expected value is negative $100. Okay, so that's the expected value. So what they're saying is that the guy would expect, the expected value for the 21-year-old. So the 21-year-old would expect to kind of lose $100 each time. So how much the insurance company, that means the insurance company is making a profit of $100 each time after he paid $250. So if they just wanted to break even, they wouldn't have to charge the whole $250. They could charge $100 less than that. They could charge $150. Okay? It says, given that the expected value is negative, why should a 21-year-old male or anyone else buy insurance? So that one's just kind of a life lesson. We'll go to number 9. So it says, assume that a procedure yields a binomial distribution with a trial repeated n times. Use a binomial probability table. So here we can also use the whenever it's binomial, PDF on our calculator. And remember, we're going to put the n value, comma, the p value, comma, the x value. So here we'll do binom PDF of 4, comma, 0.10, comma, 2. So we're going to do second distribution. Do binom PDF, put in 4, comma, 0.1, comma, 2. Okay, and we get 0.0486, which it tells us to round to 3 decimal places, so it rounds to this answer they had. Okay, so number 10 here says, determine whether the given procedure results in a binomial distribution. So it says spinning a roulette wheel 10 times, keeping track of the occurrences of the winning number 16. So here we're either saying, is it a 16 or is it not? Okay, so those are our two choices, and that's where I think you probably got caught up. So this would be a binomial distribution. So the two choices are either 16 or not. The trials are independent. When you spin the wheel, it doesn't matter what happened on the last one. You would have the same probability of getting a 16 each time, and we're spinning it 10 times, so that's our fixed number of trials. Okay, so it says a dice is rolled 17 times and the number of 2s that come up is tallied. If this experiment is repeated many times, find the standard deviation for the number of 2s. So here, this is a binomial situation. I'm rolling a die, so the standard deviation is going to be that formula we did before, the square root of n, p, q. Now here we're rolling it 17 times, so that's our n. If we're rolling a 6-sided die, the probability of a 2 coming up, there's 1 2 out of 6 sides. And then q would be 1 minus 1/6, which would be 5/6. So we're going to put that in the calculator. Again, be careful about putting too many parentheses. So here we'd have 1.5. And then the last one, it says use the given values of n and p to find the minimum usual value and the maximum. So the first thing we need to do is find our mu and our sigma. So mu is n times p, and sigma is the square root of npq. So here this would be 1348 times 0.91. So 1226.68. And then for the square root, sorry, the standard deviation, we'd have the square root of 1348 times 0.91, and then 1 minus 0.91 would be 0.09. So 1348 times 0.91 times 0.09. So we're going to have 10. This isn't rating, sorry. 10.51. So the minimum value is the mean minus 2 times the standard deviation. So we're going to put this value here, the 1226.68 minus 2 times the 10.51. And then the maximum is just adding instead of subtracting. Okay, so for our minimum we'll have 1226.68 minus 2 times 10.51. So our minimum value is 1205.66. And our maximum value is 1247.7. And you can see within rounding, that's what those are right there. Okay, so let me know if you have any other questions. Take the practice test again. If you're ready, then you'll take the test. If you don't pass the practice test again, email me and I'll explain the study plan. We want to get you through this and the midterm so that on Wednesday you can. You also need to watch the videos for Unit 4. It's about an hour and a half of videos and take notes. I'd like you to do that before Wednesday so that in class you can work with the group in the lab so you don't get behind and have the opportunity to work with the group. And then we'll schedule a time for you to take the midterm outside of class so that you don't get behind. Okay? Have a great week. Bye.